Hey guys, in this set of videos we're going to talk about y equals mx plus b. It's called a review of y equals mx plus b because you guys spent a lot of time your 8th grade year working on this. So I don't want to say we're starting from scratch because that would assume you didn't learn anything. And some of you probably know it quite well, and this will be just a little bit of a, maybe even an annoying little review, but I won't make it too long. I just want to get in here, hit some of the key points. Now the point of doing this, before we go any further, the point is to show you how y equals mx plus b is tied to the arithmetic sequence. Okay, that's the whole idea. That's why I'm throwing this in where we are. I want to make sure they're linked together, but I thought it might be okay for us to spend a couple of days just reviewing some of the stuff you learned last year, okay? So let me hop in here and I've already got some notes prepared and talk about some of these equations. Okay, so you guys remember this good little equation. Most always 9th graders do. Y equals mx plus b. And here's an example of it. 2x plus 1, y equals 2x plus 1. This equation forms a line in the xy plane. And that's what we usually work with, right? The line is made up of every ordered pair that makes this a true statement. That is, now when you plug these in, ordered pairs have order x and y, and we did that little review on that at the beginning of the year. If you plug 3 in for y, 1 in for x, it has to make a true statement. If it does, it satisfies the equation. Then you have located a point that lives on that line. All right. Okay, so this is the graph of that equation. Yes, I put it in Desmos. You can see it right here. And I just plugged that in for our note purposes. So that's how you could graph, and I'm hoping that you guys use Desmos when you graph these as well. All right, so just some basic terminology. Where this line crosses the x-axis is called the x-intercept. That is totally different than the y-intercept. Notice I've got this labeled B. That's important because that's that same B living right there. Yes, you remember y equals mx plus b, m is the slope, b is the y-intercept. And for example, in this one, slope 2, y-intercept 1, or the ordered pair 0, 1. Okay? All right, so there's some things you can do. One thing that you can do, given a graph, you can get the slope of a line from the graph. And we're going to come back up here and talk about that in just a minute. But first, let's define slope a little more carefully than that. All right, so this is just going down, and I told you this is a brief review. It might seem a little fast, but once you start working with it, I think it'll all come back to you. All right, slope is defined to be a rate of change, actually. If x is the independent variable and y is dependent, then the rate of change is said to be the change in y divided by the change in x, and that turns out to be our definition of slope. So let's see if we can spot it here. The change in y up to over 1, I'm back to the line. Hence the slope of 2, right? In other words, if I go up 4 units, 1, 2, 3, 4, I better go over 2, right? The ratio of 2 is the slope of this line. Okay? And we'll get into some more details about that later. All right, now I know you guys remember doing this too. The slope m of a non-vertical line through any 2 points, and they're just giving you generically ordered pairs here, can be found as follows: y2 minus y1 divided by x2 minus x1. Make sure when you use this formula that y is in the numerator, x is in the denominator. I can't tell you how many students I've run into who get it upside down or backwards, and it's always wrong, okay? So we'll practice that in just a minute using our formula. In fact, we'll do one right now. So we want to find the slope of -3, 4, and 2, -3. And we're going to use, we'll just do it by hand. And if you get in a jam, maybe during one of our Zooms, I'll show you how to put this into a calculator. All right, so we're going to find the slope of -3, 4. Ooh, I want this to be a little thicker than that. And, ooh, too thick. Maybe 3 is where we want to be. And that's better. And 2, -3. All right, so we'll call this x1, y1, x2, y2. So m equals y2 minus y1 divided by x2 minus x1. And that's going to be -7/5. Right? And so we have the notion here of a negative slope. And this one happens to be -7/5. That means it goes down 7 units, right? And then over +5. This could also be, and I'll show you this later, up 7, left 5. All right, for a negative slope, the numerator can be negative or the denominator. They both can't be because it makes it a positive. So when you get a slope that's negative, it can be graphed either way. I can go left 5, up 7, or down 7, right 5. Okay, so think of this as your x direction. Negative means left. Positive x means right. And y is the opposite. It's vertical, right? So a -7 with the y direction means down. +7 in the y direction means up. And that's how we read those, okay? So let me get back to the notes here. I'll pencil that in when we get done here. All right, now this one says, find the rate of change represented by the table. All right, so basically what we want to do here is just choose some ordered pairs and calculate the slope. And what we'll do is we'll consider this y1, y2, y2, y1, x2, x1. So I'm going to take this as an ordered pair, 20, 5, 15, 4, and we'll calculate the slope that way. That's just another way you can do it from a table. So I took this from the table. Oops, didn't mean to do that. Don't do that either. Okay, so we got 15, 4, and 20, 5. So m is 5 minus 4 divided by 20 minus 15. And I think that's 1/5. This pen gets kind of sloppy sometimes, you guys, because somehow it's lagging a little bit. So that should have a slope of 1/5. All right, now, as we go down here to talk about slopes for just a minute, positive slopes go up if you think of it from left to right. If you're reading a graph from left to right and it's increasing, that's a positive slope. If it's decreasing from left to right as you read the graph, it's a negative slope. Horizontal lines, think about this, have no rise over run, so it's 0 over some run, so it has a slope of 0. And we don't talk about vertical lines having slope because that means it has no run, which is divided by 0, right? It has no run and all rise. Finally, we have the slope-intercept form of a linear equation. Y equals mx plus b. I've already talked about that once. I just thought I'd put it in here formally. M is the slope and b is the y-intercept. And the final problem I want to work here, I know I'm kind of running a little bit long with this video. It says, write an equation of a line in slope-intercept form from a graph. All right, now I'm given a graph and I'm asked to write an equation of a line. This is the first thing we've talked about with equations of lines, but I think we can manage this. So I'm going to go ahead and do it live over here on this problem here. And all right, so the first thing we need y, we need an m and a b, right? And I can see b right here. B is where it crosses the y-axis. That's -4. So it's really a matter of calculating the slope. So I need to find where, well, we know it goes to that point, right? So that's up 5 over 2. So it's a slope of 5/2. So I'm going to say y equals 5/2 x minus 4. And that's your y-intercept set -4. Your slope is up 5 over 2. And it'll do it again right here, up 5 over 2. And that's how you do those. Anyway, give these problems a shot. You should have a little problem set that goes with this. And it's just to get us used to thinking about these things again as we wrap up the arithmetic sequence unit. And I will see you in the writing equations of lines video. All right, thanks for watching.